What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
No contact. The task of the throttle position sensor, or DPDZ, is simple: to transmit to the electronic engine control unit. ECU to the ECU, electronic engine control unit. Every time the driver presses or releases the accelerator pedal, the choke changes its opening angle, which means the engine needs to change the amount of fuel supplied to keep the quality of the fuel-air mixture close to stoichiometric 14.7:1 and slightly adjust the ignition advance angle. Problems with the mixture and ignition advance angle will occur with any problem with the ignition timing sensor if there is no signal from it at all or if it is incorrect. Since the sensor only needs to supply one value, the electrical part of the sensor is primitive. There is only one output voltage value, which varies from about 0.4 to 5 volts depending on the angle of the choke, and a constant supply voltage from the vehicle's onboard network to keep the sensor running. This part is the same for all of the air restrictors, but the mechanical part can be different. More often the contact or film resistive sensor fails, and the main source of the problem is the contact itself. In this type of sensor there is a slider which runs on resistive tracks, in simpler terms on long tracks with high resistance. This thing works on the principle of a variable resistor. When you move the slider, the resistance changes and therefore the output voltage, which is a signal to the ECU. Simplicity is, of course, good, but in the case of a film-resistive sensor, this simplicity is often the cause of its failure. More precisely, where of the mechanical part, the sensor itself or the track. From constant movement they gradually wear out, and in one not very beautiful moment the contact between them either disappears or becomes unstable. In the first case, there is no signal on the ECU, in the second case it is there, but incorrect. As a rule, it is jumpy. Both the first and the second are bad, because the ECU requires the exact value of the flap opening angle to work properly. For example, it is open at 12%, that's what the ECU sees, and if the driver presses the gas and opens the choke, for example, at 82%, the ECU should see the whole process with a smooth change in the voltage of the DPDZ signal from corresponding to the opening at the beginning of the gas pedal movement to corresponding to its end. And in the end it can see that first the damper was opened by the very 12% and then sharply by 82%. And in this case there will be no acceleration and moreover no pickup. When pressing the gas pedal, there is no change in the DPDZ position, there is no fuel. The car can twitch if suddenly there is a contact with the slider on some part of the resistive track, but it will not drive normally. In general, what is described above is the most common trouble with DPDZ. But, unfortunately, it is not the only one. Less frequently, the slider drive itself can wear out in this type of air restrictor. It is almost exotic, but it happens. The second type of choke position sensors is non-contact or magnetoresistive. There is no mechanical contact here, and there is nothing to break inside the sensor. There are no mechanics there. However, both types of sensors have a common weak point: their wiring. Here the faults are classic, either a break or a short circuit. And there is no difference in the ways of checking the sensors, but about it a little lower. For now, let's talk about the usefulness of the scanner. You won't figure it out until you turn it. What's bad about a DPDZ failure is the list of associated problems. If the wear of the hub bearing, stabilizer bar and a bunch of other parts can be determined at once, then with the damper sensor we'll have to work. And what else to do if there are dozens of different symptoms of malfunction? The most obvious sign of a malfunction of the DPDZ is unstable idling. However, it can be so unstable that the last thought about the choke sensor may come last. The idle may just float, or it may float so much that the motor will stall on its own. However, the same thing can happen for a myriad of other reasons, ranging from crankshaft position sensor glitches to air intake. Moreover, the other symptoms will not add clarity either. And there are many of them: reduced power, increased fuel consumption, reduced dynamics, lags and jerks during acceleration, and simply unstable, according to feelings, wrong engine operation. It is impossible to make any definite conclusions on these signs, but you can replace half of the car, spend a lot of money and stay with the same malfunction. Therefore, I repeat once again, it is best to start repair with diagnostics. Especially since it is very easy to find the faults of DPDZ with a scanner. You can start with error search. In the case of the air brake, the codes can be different. For example, P0120, P2135, P0122, P0123, P0220, P0222 or P0223. If any of the codes in the errors is present, it is desirable to conduct a test of the damper with monitoring of the sensor readings in the online mode. When changing the angle of rotation of the flap should be noticeable smooth change in voltage from the sensor signal contact and the opening of the flap in %. If there are spikes, the sensor will have to be replaced. Unfortunately, not everyone has a scanner at home, so let's see how to check this harmful DPDZ in another way. For this other way you will need a simple voltmeter, i.e. any multimeter. The check will take place in 3 steps. At the first stage it is necessary to check whether the voltage is supplied to the remote sensor. To do this, remove the sensor connector and measure the voltage on it. If we manage to find a suitable 12 to 13 volts, all is well. If not, we need to look for where this voltage has gone. There may be a break or short circuit in the sensor wiring. If everything is all right with the voltage, we move to the second stage, look at the extreme values of the sensor signal. To do this, first look for a signal contact from the sensor, connect the minus terminal of the voltmeter to the mass, plus looking for voltage of 0.5 to 5V on the pin of the connector. As soon as the required pin is found, and it is not difficult to do, there are only power and signal connectors, turn the damper to the extreme positions and watch the voltage. When the shutter is fully closed, the voltage should be about 0.4-0.6V, when fully open, more than 4V. The meaning of this operation is that very often in the contact sensor's resistive tracks are worn out in the most extreme position. Corresponding to the fully closed flap, the slider is there at the moment of idling, from there it starts its movement every time you press the gas pedal. If the voltage does not exceed the normal limits in the extreme positions of the damper, we proceed to the third stage. It is important for us to find out whether there are no data spikes from the sensor. It is good if you have a scanner, that you can see the surges not so much by numbers as by a graph, if the scanner has the ability to see this information in the test mode and display it graphically. But with a multimeter you will have to be careful and attentive. Theoretically, of course, there is nothing complicated, it is necessary to smoothly turn the throttle and simultaneously monitor the voltage, which shows the voltmeter. The figures should change smoothly, corresponding to the rotation of the throttle. If there are jumps, then the slider or track has defects and the sensor can no longer work normally. What to do? The throttle position sensor is a reliable part and rarely fails. There is no way to prolong its life, mechanical wear of the contact throttle position sensor cannot be avoided. Trying to repair this sensor is a thankless task. It is easier to buy a new one, which is usually done. It should be remembered that driving with a defective sensor is usually possible, but difficult. In addition, a malfunction of the ignition advance sensor can lead to more serious failures. For example, due to incorrectly set ignition advance angle or poor mixture, the engine will not only pull poorly, but may overheat. Appeared jerks at acceleration will not like the transmission, especially automatic box, of any type. Well, and to go to overtaking and suddenly lose traction, it is simply dangerous. So, if any signs of DPDZ malfunction appear, it is better not to postpone diagnostics and repair for a long time, repair postponed for an indefinite period of time usually turns out to be more expensive than timely repair. In conclusion, understanding the internal pressure sensor is crucial for diagnosing issues related to fuel efficiency and engine performance. As we've explored, when this sensor malfunctions, it can lead to excessive fuel consumption, reduced thrust, and an inability to maintain idle, ultimately affecting the overall functionality of the vehicle. Regular maintenance and timely inspections can help prevent these breakdowns, ensuring that your engine runs smoothly and efficiently. Thank you for watching, and be sure to stay tuned for more insights into automotive technology.